about a project called Bird, a mouse for VR. First and foremost, in case I'm ever giving this talk somewhere where not every person in the room knows me, I'm Aubrey. I am a VR researcher and interaction designer and a first year PhD student in the Interdisciplinary Design and Media program at the College of Arts, Media, and Design. I am supervised by Casper Harteveld in the Ghost Lab. Those are the symbols for CAMD and the Ghost Lab. So, how do we grab things in VR? There are two most common interactions usually in use nowadays. The first of them is direct interaction. Over here, there's a little GIF of just inside of the Oculus home screen. This is one of the two ways you can interact with menus. It's like grabbing things in physical reality. You can poke stuff, you can grab stuff, your hand is mapped to where your hand really is. Very intuitive. Unfortunately, it does not let you reach beyond the natural working volume or arm's reach. If something is beyond as far as you can grab it, if your hand is always where your real hand is, you can't really do anything with it. The other common way to interact with things in virtual reality right now is using raycasts. Here's an example of that also in the Oculus home screen. They are an instance in which you have basically a little laser pointer that comes off of your hand, and you can click stuff with them. They're very fast, and they're very efficient, especially for working on like flat 2D panels of various types. Unfortunately, they also run into disambiguation problems. This means that if there are multiple different objects which you could mean to select, and the ray intersects multiple of them, there's no way to clearly differentiate which one you mean to select. Raycasts will usually default to grabbing the first one, so if something is in front of something else, it's hard to grab the thing that's behind the other thing. They also give you no control over distance. This means that if you select something, it stays at the same point along the ray. You can't bring it closer to you, and you can't send it farther away without some additional step. Point cursors resolve this by being a point along that ray, rather than the whole ray itself. They usually have some mechanism for moving the point along the ray. Bird, the technique I'll be talking about today, is an instance of a point cursor. The way that it works is that if you have a ray out from the center of the palm, if you open the hand, the bird cursor moves along that ray farther away, and if you close that hand, it moves closer again. The pointer finger is reserved to click. It allows you to do interactions like this. This is using one instance of the bird on each hand to draw some figure eights. So it gives you very smooth, intuitive control over a point in 3D space that can be basically any spot you can see. So, how does it work? Well, this is a hand. We track a number of points on the hand. In the actual code, it's like 20 something. For the sake of simplicity in this diagram, we're going to show it with 3. We calculate a sphere of best fit for the tracked points. There's a lot of math that happens under the hood there, but basically, of all of the points, we make a sphere that is as close as we can get to fitting all of them. This is the center of that sphere of best fit. We draw a ray through the base of the palm and the center of the sphere, out from the hand. The cursor is a point along the ray, much like the cursor on a computer mouse that you might be familiar with. The position of the cursor along the ray is determined by the distance between the base of the palm and the center of the sphere. This means that opening your hand very wide moves the bird very far away. It lets you do interactions like this. Here we're going to use the cursor to select this beacon over there. Click on it to teleport to where it is. I'm going to pick up this pear, which has its tracking speed set to medium. This means that as the cursor moves, it's smoothed a little bit to not move too fast. And then I'm going to reach over and grab this pomegranate, which has its tracking speed set to very fast, so it's always at the position of the bird. And then I set them both on the table. It also means that I can grab things that are really far away. For example, this whole house I can pick up and bring overhead and maybe put on the other side of the environment. Like that. Cool. So, the bird opens a new design space within mixed reality. We're doing some work on exploring what that design space means. Mechanics that are built on top of the bird could use any of 4 components of the interaction. They could be centered around the object, which is held by the cursor itself, which is a point in 3D space, a ray drawn out from the hand, or the path drawn through space over time by the movement of the cursor. This is a little framework of those 4 possible interaction components. We're working right now on building demo applications that use mechanics using each of these 4 possible interaction components. One of them, the fruit replacement demo, involves picking fruits off of a tree, sort of like the way that we picked up the pear and pomegranate earlier, putting them in a basket, which is possible to do with a raycast because you're just pointing at stuff and clicking on it. So then we also give people a basket full of other fruit to pick up and put on the tree, sort of like decorating a Christmas tree. A little more surreal and an interaction that you can't really do with a raycast. We are creating a demo for the cursor. This one already exists. It's called the Fireball demo, in which you are a wizard and you pass the cursor through various chalices to pick up fireballs, and you can run it into some towers to blow them up. A mechanic that uses the ray is pointing. If you have 2 different people in an environment, you can use the ray and the ability to control the position of the point along the ray to clearly point to another person where something is in 3D space. So we're making a little application in which you go bird watching with someone else and you can point to where the bird is, but also how far along the ray it is. And finally, we're building an application that uses the path, which is a painting application. Think tilt brush, but really big. So if you'd like to see more details about this project or follow along with it as it grows and evolves or talk to me more about it, this is my name and email address and website, and that is a GitHub repository at which you can download it and hear more about it and start working with it right now because it's open source. Yeah.